imagine you are a molecular architect and you have the power to build complex structures from small pieces. Sounds like magic? Well, in the world of chemistry, this magic is real and it is called the Grignard reaction. What is Grignard reagents? It is basically the derivatives of alkyl halides with magnesium in ether solvent. These are organometallic compounds. This was first prepared by the French chemist Victor Grignard in 1900. You can see Victor Grignard on the right side of the screen. This is the important reaction in organic chemistry. He was awarded Nobel Prize in 1912 for the discovery of Grignard reaction. Let's see the preparation of Grignard reaction. In the first step, the reaction of magnesium metal with alkyl halide in the presence of dry ether, sorry. Let's see the general reaction of the preparation of Grignard reagent. In this reaction, we take alkyl halides react with magnesium metal in the presence of dry ether, and with that R magnesium H alkyl magnesium halide. You can see charges, the partial positive charges will appear on magnesium, and on alkyl and halide both have a partial negative charge. Let's see the example of ethyl magnesium bromide. How we can prepare it? Simply, you can take ethyl bromide, react with magnesium metal in the presence of ether. You will get ethyl magnesium bromide, which is a Grignard reagent. This is the ethyl magnesium bromide. Point to remember, our reactants must be dry and pure. Why is that? Because ethyl magnesium bromide is highly reactive. It can even react with impurities. Now you can imagine how reactive this non-reagent is. Now we will list this the reactivity of Grignard reagent. For this, we have to see the reactivity of alkyl halide first. So this is the order of reactivity in terms of alkyl halide with magnesium. You can see alkyl iodide is highly reactive than alkyl bromide, and which is more reactive than alkyl chloride. Now, for a halogen, methyl halide is highly reactive than ethyl halide, which is more reactive than propyl halide. Why is that? Because methyl don't have bulky groups on its side. That's why methyl halide is the most reactive one. Let's move to next. Now we will see the structure and reactivity of Grignard reagent. Grignard reagents are much reactive than most of the organic compounds due to the nature of carbon magnesium bond, which is a highly polar. Now, look at the structure of Grignard reagent, and you can see partial positive charge will be on magnesium. That magnesium is more electropositive than carbon, and carbon magnesium bond is covalent is highly polar, giving alkyl carbon partial negative charge. As you know, negative charge on carbon is unusual, which makes highly reactive toward electrophilic centers. This is highly reactive reagent, and most reactions stored by Grignard reagents are exothermic. Now we will discuss the mechanism of the non-reagent. For this mechanism to remember easily for you, I come up with a word which is a CAR. C-A-R. Now I will show you how you use this word to remember this mechanism easily. The first letter from the mnemonics is CAR is C, which is the first step in the mechanism of Grignard reagent is create the Grignard reagent. Now you remember how C is used in the first step. The second letter is, as you can previously see how did not reagent form. I just show here for your quick revision. Let's move to second step. That starts with A, which is the attack the carbonyl, which is attack the carbonyl. In the first step, we will make the not reagent. We will use this reagent in the net in this step. Now we will react the not reagent with formaldehyde. This alkyl attack on the carbonyl carbon of the formaldehyde. This bond will shift toward this, and we take methanol in this step. This alkyl will attack on the carbonyl carbon of the methanol. This bond will shift toward this, and we will get an intermediate compound, which will be used in the final step of this mechanism. Let's move to the third step of this mechanism, which starts with the letter R, which is rearranged with hydrolysis. To save time, we will follow the reaction from the second step. Now we add hydronium ion in this intermediate product, and we will get primary alcohol plus MgBrOH. This is the mechanism of the Grignard reagent. You will clearly get the idea how this mechanism and how these mechanisms usually work. This is a great trick to remember this mechanism. Let's discuss some of the famous example of Grignard reagent. Our first example is with acetaldehyde, which is the ethanol. Now let's see how these Grignard reagents react with acetaldehyde. Now this negative of alkyl halide will attack on the electrophilic carbon, and this bond will shift toward this. And with that, the intermediate product, which we discussed in the mechanism of this reagent, of this reaction. And the remaining species are written as you can see. Now we add hydrolysis in this intermediate compound. After the hydrolysis will be done, now we get the secondary alcohol from this reaction. And this compound is 2-butanol. Now we see how this rearrangement takes place. This negative on the oxygen will attack on this hydrogen, and this bond will shift toward oxygen. This is 2-butanol or secondary alcohol. Let's see the next example, which is the reaction of Grignard reagent with acetone or propanone. Just remember the steps of the mechanism. You will easily solve this reaction. We will take ethyl magnesium bromide, react with acetone or propanone in the presence of a dry ether, or you can simply write ether. This partial negative on alkyl will attack on the electrophilic carbon, and this bond will shift toward oxygen. And with that, the intermediate product as in the last step. Here, there's a little mistake. I accidentally miss one methyl group. Sorry for that. When we do for the hydrolysis of this compound, we get tertiary alcohol or 2-methyl 2-butanol. It's 2-methyl 2-butanol, a tertiary alcohol. You can see three different groups are attached to the carbon, which is attached to the hydroxyl group. Let's see the last example of this of the non-reagent with carbon dioxide. Starting with take ethyl magnesium bromide, react with carbon dioxide in the presence of dry ether. Now, this negative charge on the alkyl halide, which is attached to magnesium, this partial positive charge, will attack on the electrophilic carbon of the carbon dioxide, and this bond will shift toward oxygen, and with that the intermediate. I highlight the oxygen atom here for your better understanding. Now let's do the hydrolysis of this intermediate compound, and with that this compound is known as propanoic acid. Now remaining products we can write as usual. There are various examples of this with non-reagent reaction. You can try as much as you want. But remember the key phrase, which is a CAR, R. C. To read the Grignard reagent. A. Attach the electrophilic carbon, or R. Rearrange the compound. Now we will see the application of this reaction. The major use of Grignard reagents are in pharmaceutical industries, which is in pharmaceutical industries there is a medicine known as aspirin, ibuprofen, where this Grignard reagents were is used. If you have any question related to this topic, you can drop a comment. If you have any question related to this, comment down below. I will happy to answer it. Like and subscribe for more. I'll see you in the next video.